I'll be presenting the customized like LLM using Unsloth. So like I'll be demonstrating a complete like usage of Unsloth, like using various pre-built LLMs that are like Llama 3.1, Mistral NeMo 12b, and Gemma 2, and Pi 3. That is a medium one. And like after this is the part A, and part B continues the pre-training of the TinyLlama that is in the specialization one, that it has a models of converting from normal to Hindi and etc. And not only in this specialization, it has a variety of like all the Spanish and language model for that. And after that, the chart template showcase is this one. And the preference based reward modeling like I have performed on the collab link is this. And after that, the pre-training from the checkpoint is this. And the mental health, the support chatbot is this one. And the export the interference with the Llama. So this contains the like overall the assignment. And like if you move on to the Unsloth, the basis one, so here is the first one is the fine tuning the LLMs. And as B, C, and D, and E, as explained in the collab, like man will be in the same order as the customized LLM of the Unsloth assignment. So this is the base that the file which we get from the assignment. And I built all my files similar to with the help of this, and along with the ChatGPT extensions. And to begin with, the first is the installing the dependencies for the this one, the Llama 3.1 task, where I have imported the collab modules tokenizers to load the module. And this is the example for that. And next we move on to the defining a tiny code of generalized data. That is, this is my input data, write a function to revise a string and example, so it understands the codes, and it writes a simple logic for that. And text for the cell 4 is the manual prompt formatting for the chart, and a no chart in the template, and it was able to predict the prompt. And I'm happy to 100% for this case. And followed by next is the cell A, where we robust interface extraction, where so here is the like fully decoded output and extracted assistant response for this. And this is the example for the inference with the pipeline and the generated prompt for this. So here is the we write a generated prompt for the factorial code. So this generated the complete code, and as well as the else logic for the response for that one. And also the extended clean assist for the response is this. So here the factorial is 0 and it returns 1, and if it's the not 0, then it logics the this function and it performs it. So this is the function, and this is the example for that. And there's a simple example for the Unsloth using 3.1, and the same demonstration like I'll be performing for the following cases, that is Mistral, Gemma 2, and etc. and so on. So and if you move on to the next task, that is using a LoRa fine tuning. And to these are the installations for this file, and loading the install model with Unsloth, and creating a small chatbot conversations for this one. And this is the prompt for the generated, and these are the prepared LoRa for training. And this is the training loop for that, and inference for the backlog training, and here is the assistant response for that we got. So and the same ways as IAB. And this is the third example for the Q&A based installation dependencies for gamma 2 9b. And this is my prompt, and these are the outputs I got for this. And preparing a lot of fine tuning is this this is the part. And train and test the models is this one. And inference cell is this part, where this is the assistant response we got from the code. And at the last part, where we have the summarizer part, where summarizer is the Pi 3.5 mini, where we'll be using this one to demonstrate the examples of like how the Pi 2.5 data, and like how it handles and everything. So it follows the same order for this. Like these are the input created many summarized data sets. And this is the change say style for that. And apply a LoRa for the fine tuning, and this set a transition for augmented trainings and etc parts. And like later on, the step 7 is the inference summarizations for this. And this is the amazing regret, the climate and the stress call we got for the part 1. So completely, so this completes the part 1 of the task. And we'll be moving to the part B, that is continue pretending pre-training, sorry. So this will move on to the B section, where in the continuing pretending pretending languages, where here we use the onslaught 1 to install directly from the github file. And this is the torch version, so like which model has been loaded, and all the onslaught files has been installed or not. To cross check, we have run this file. And this is a major parameters, like we'll be performing the parameters and the length of the load models and etc. And this is where we load the base model set for the significance. And this is the data set name is MC4, and the target languages and etc. Like here is the one. So for example, so here is the high for Hindi is the targeted language, and same as goes for the LoRa and all the transitions as we configure the passive TTRNs for constraint pretending and output directory for the Llama 3 based pretend for patch 1 or run 1 files. And these are the training examples, and it divides 0.5 100 MB of the file. And this is the training loop. And this is the where we saving the final LoRa adapters. And here we run the inference test cases and etc. So here we is the generated output from the normal languages to in this, or generated for French and like other prompt is the one. So here as a base one I have mentioned as Hindi, and finalize it can be done in any other languages, as it's listed on Collab and Onslaught. So we can directly load from the languages and from the LLMs, and we can train on any language which we have. So this completes the part B, and here we go to the part C. That is a chart template. So in the chart template we perform the same steps of here. And here we touch the files, and for the classification we use the class chart templates. And here is the one where we run the model and configuring LoRa for the models and the dataset for it. And here is the formatting the functional definition of the data, and applying the formatting of the data will be performed in this. And here is the STFF and train for the model. And is the starting classification fine tuning, and the training is completed. That is, the training is finished in 2.13 minutes, and example and adaptive saved is done. And the conversion of the chart is the done in this. And this is the where we did the loading models and the testing each model, like how many tokenizers has been loaded for this model. And here is a configured LoRa, and the training parameters and other examples to showcase it, like what are the trainable belts and etc. And so in this the formatting functions are defined in this manner. And postfully the different use cases of strn functions and etc. And here is the extending the max context size of a TinyLlama. And this is the examples for that. And like 1,000 examples we have run, like what are the strings and the song or the file on the on the basis of the English vocabulary, either it's a noun or a other scenario, it will load the data and it will identify the text from that. And here is the other examples of inference with the test data set is done on this year. And this is a multiple data set for the single fine tuning is done in this. And these are the examples for the different multi-modular data. And here is applying the all the formatting and combined data set is this. And here we I'll show the examples of a multi-model data inference set for this. And this is the conversation, and this is the coding for that it happened in the background. So it understands the whole task, and it ran on the conversational and chart templates scenario wise. And next we go to the D part. From the D part I'll onwards I'll be explaining in the next video for this part.